The Lifetime Achievement Award recognizes individuals who have shown outstanding leadership in promoting the development and use of flash memory and associated or related technologies, including creation or promotion of an important storage technology or related technology, leadership of a major memory or storage business, company or business or academic program, and bringing the technology to a new and important application. Over the past 14 years, FMS has awarded that distinction to 17 individuals, all of whom had a marked impact on the industry. This year's recipients are being honored for their invention of 3D NAND flash, which overcame the scaling limit that threatened to end Moore's law for NAND flash. They are Hideaki Aoichi, Ryota Katsumata, who will be with us to receive the award, Masaru Kido, and Hiroyoshi Tanaka. Before explaining this, what this team created, let me talk a little bit about Moore's law. Gordon Moore, who passed away last year, but he was a founder of Intel and a respected visionary in the world of semiconductors. He plotted this chart, which was published in a 1965 article about the release date of chips and what their densities were, saying that with the dotted line by 1975, that the number of components in an IC might get up to 65,000. When that became true, this became known as Moore's law. So let's look at some more recent data to see how that has worked for us. This is the average density of DRAMs for the past 20 years. It shows that we've been able to keep increasing the number of devices on a chip. And the result of that, which Moore also projected, is that the cost per device has gone down. It didn't end up being able to be kept up. Flash ended up having a problem. There's capacitance coupling between adjacent floating gates in flash that caused problems because that capacitance ended up giving greater coupling to the adjacent gates than what we had to the gate that was trying to control. And so we ended up hitting a brick wall at 15 nanometers. And that was something that these engineers at Kioxia decided that they'd try fixing. So what they did was they took a string of NAND flash gates and they said, what do we do with this? What if we turned it sideways and put it together and then made a whole bunch of these together at the same time? That's a way that we could end up getting Moore's law scaling at price without actually reducing the size of the transistors. And they named this BiCS flash technology. BiCS at the time was defined as being bit cost scaling. The way that they built this, the production process, is very different from what I just showed you. It's called punch and plug. Alternating layers of conductors are then, after they're deposited on the surface of the chip, then billions of holes are etched through these layers. The holes are then filled with films that created the actual bit cells. This straightforward process has been used for the past 8 years to produce 3D NAND, which has rendered the original planar NAND obsolete. Over that time, NAND's price per gigabyte has dropped from 28 cents to about 6 cents, proving that BiCS has achieved exactly what the developers intended by scaling NAND flash costs to roughly 1/5 of their 2016 level. FMS is by no means the first organization to recognize this achievement. In the past 4 years, this team has been awarded 2 important medals from Japan and 1 from the IEEE. Today, FMS recognizes these researchers' phenomenal contribution to the flash memory business and to the industry as a whole by showing how ingenuity and innovation can be used to help Moore's law continue despite a threatened scaling limit. Please join me in congratulating our honorees, Kioxia's 3D NAND development team, and I will ask for Ryota Katsumata to now receive the prize on behalf of the team.
Okay, can I start?
Yeah.
Oh, ladies and gentlemen, and that's team member of Future Memory and Storage Community. And on behalf of development teams, it's my great pleasure and honor to receive the Lifetime Achievement Award from the Future of Memory and Storage. As I accept this award, I'd like to introduce our teams and its members. So, let me talk about what made our teams so good, why we could innovate and create Big Splash. There were some characteristics that made our teams so good, our teams. So, first of all, we are well trained with the skill to develop the complex structure and establish device design for manufacturing. Originally, these members come from the DRAM development, who leading the DRAM advancement, including not only trench DRAM, but also stacked DRAM. In early 2000 year, DRAM structure had been already complex and constructed in 3 dimensions. Therefore, we had the knowledge and skill to conceptualize complex structure for NAND flash memory. And second of all, there were the psychological safety consideration in our teams. I guess that everybody will know about the famous Google great experiment of the project Aristoteles, which highlighted about importance of psychological safety. So we had it. That characteristics mainly due to our boss, Aochi-san, who never denied any idea that anybody introduced in our teams. Even in that, somebody think about new idea that is so funny, it was okay. So we had started to expand such a concept. It became a logically doable idea. Aochi-san always saying, think and think until brain boils. So therefore, the picture of us looks so serious. Everybody shows the serious expression face. So our brain is always boiling. So that shows. And finally, we had the idea. One day, Aochi-san brought out the new concept of the punch and plug process for Big Splash. He had a eureka moment on the train from his home to the office. Okay, so let me introduce our member. Left-hand side, Aochi-san, he is our boss. And I'm Katsumata, mainly mask design and simulation. And middle guy, Kito-san, designs the cell devices. And Kido-san, a little bit confusing, the Kido-san design the integration, the process integration. And last guy, right-hand side guy, Tanaka-san presented the world first proposal of Big Splash concept in VLSI Symposium in 2007. And of course, all of Kioxia member had a newly established and related technology to realize the big flash innovation entirely. So that is what I like to say. So thank you very much for this incredible honor. Thank you.
Congratulations. So, yeah. We're going to do a picture? Oh, okay.